Hello, this is Dylan Moore, Lab 4 for CPSC 4550. We're going to go ahead and get started. I've already got my trace, my initial trace done, and I've got the two packets that we'll be primarily using in this first part of part 1 already pulled up here, and so we'll go ahead and get started with that. It says, what is the 48-bit Ethernet address of your computer? And we'll start with this one because my computer is the one that sent the GET request and initiated it. And if you look under Ethernet right here, you have destination and you have source. And under source here is going to be my computer's Ethernet address. And here initially you've got Intel 82, B2, A7, and that's kind of like a device identifier. So that's just kind of like, that's going to be the same. It's going to be on the back end of the actual Ethernet address, but the full Ethernet address for my computer is F4463782B2 A7. And then on question 2 it asks what's the 48-bit destination address in the Ethernet frame. And that is this little guy right here. So it's E46CD1F9C499. And as you can see, the type of device is different. It's a Calyx instead of an Intel. And as you can see, those numbers, or those little hex values, line up with these hex values. And it's not the Ethernet address of the actual physical website, but it is the Ethernet address for a device that picked it up and routes it to that other physical location. And then we get to 3, and it says, give the hexadecimal value for the 2-byte frame type field. What upper layer protocol does this respond to, or does this correspond to? And if you look under Ethernet again, you've got type right here. It tells you right here the type of upper layer protocol that you're using, and it is IPv4, which has got its listed, but this is the actual hex value over here, which is 0x0800, and that corresponds directly with IPv4. Like IPv6 has a different hex value, and other upper layer protocols have a different hex value, but if it is 0x0800, it will correspond to IPv4 version 4. And then it says how many bytes from the start of the Ethernet frame does the ASC2G in GET appear in the Ethernet frame? And so if we want to look at that, we're going to have to look at our HTTP. And to find that, all I have to do is, we found our GET request that's made right here. I click that, and this is going to show the entirety of this right here. And this other part, well, not the entirety, but it's like the entirety of the GET request there. And if we look right here, this one, if we click this one, this is the actual first 3 letters of the GET there, and you can see that right here. So technically, this starts, the first G appears right here out of all of our data. And if we look here, we can count through the bits, and that will be 16, 32, 48, and then 2, 4, 6, 54 bytes into the packet is where that G appears. So now we're going to look at the other packet that responds to the request. And that's the questions are going to be kind of similar. It says, what is the value of the Ethernet source address? And let's go ahead and look. So here we have our source right there, which is the same as the destination on the last one. So that's the one that received it. It's sending the response back. And that source address is E46CD1F9C499. And again, it's not the address of the well, this address is the source of the Gaia CSU mask, or the router that's routing things to it, or the device that's routing things to it. It's not the actual Gaia CSU mass edu physical location, but it is a location for a device that is getting that information from there to here, or sending it from here to there. And 6 is, what is the destination address in the Ethernet frame? And the destination is my computer, and that address is F4463782B2A7. So we've got that. And then we go to 7, which is give the hexadecimal value for the 2-byte frame type field. What upper layer protocol does this correspond to? Again, it's going to be the same. It's going to be IPv4 version 4, and that hex value is going to be 0x0800. That corresponds to that IPv4 specifically. And then it says, how many bytes from the very start of the Ethernet frame does the ASCII O and OK appear in the Ethernet frame? And we're going to kind of do the same thing that we did to figure out where the G is in this packet, in the previous packet, but we're going to look for this O right here in this packet. And so to do that, we're going to go back down here to HTTP, because that's where our initial thing is going to come from, and we're just going to click this, and it's going to highlight all the bytes that are there right now. And status code description, okay. And response version HTTP /1.1. That's going to initiate this right here, this first part right there. Status code 200, which is okay. So this is actually where the initial letter appears at, which is going to start right there where that 32 is, that's been highlighted in green. So that's only going to be 9 bytes in. Okay. So now we're going to move on to the ARP caching portion of the lab in part 1. And I've already got my ARP pulled up right here. I'll go ahead and get into the questions here. It says, how many bytes from the very beginning of the Ethernet frame does the ARP opcode field begin? We need to go ahead and find our ARP first. There we go. So now we have all of our ARP data packets here. And again, the question is, how many bytes from the very beginning of the Ethernet frame does the ARP opcode field begin? So if you look down here, ARP, in this section, it highlights everything that's in that. But if we go down here to opcode, it's a request, which is signified by the digit 1, and you can see that highlighted right here, 0001, and that is actually our opcode. So the bytes from the beginning of this frame is 16, 17, 18, 20. So it's 20 bytes in is where this opcode starts. And then number 2 is, what is the value of the opcode field within the ARP payload part of the Ethernet frame in which ARP request is made? And the value is request 1, because that's gonna signify what type of opcode this is. This is a request. And it says, does the ARP message contain the IP address of the sender? And it does contain the IP address of the sender, because you can see down here you have the MAC address right there, which is our hex values, and then if you look right here, we have our sender IP address, and that's 192.168.1.2.1.4. So we do have our IP address, and it says, where in the ARP request does the question appear? The Ethernet address of the machine whose corresponding address is being queried. And the question is going to be our target, and that appears towards the end. And the Ethernet address right here is 000000000000, which means that that doesn't have a Ethernet address assigned yet, which means that we're still trying to find it. And now we're going to go off of the reply that was sent. And so if we go down, we're looking at here, we have right here's our request. We have another request, which is similar. This is the broadcast. They broadcast it out first to try to catch anyone that try to catch the IP address 192.168.1.151, and then that IP address responds, or the device that finds that IP address responds to ship you the physical address of that, which is the Ethernet address. But anyways, we're going to move on from there, and again, request there, get down here, and now we have reply. So this is our reply from our initial request. And the question is, how many bytes from the very beginning of the Ethernet frame does the ARP code field begin? ARP opcode, and we got 1620. We got 20 bytes in. That's where our opcode is again, and see it's changed to a 2 there. That signifies that this is a reply instead of a request, which was a 1 from the previous one. And it says, what is the value of the opcode within the ARP payload part of the Ethernet frame in which an ARP response is made? And that is again reply 2. And then we go to 3. Where is the ARP message? Where in the ARP message does the answer to the early ARP request appear? The IP address of the machine having the Ethernet address whose corresponding IP address is being queried. And so this is actually in the sender IP address, and the sender MAC address, because this is answering that question. Because when we shipped it out first, those were all zeros for the target, because we didn't have a physical location for that, and now we do have that location, that Ethernet or MAC address, and it's F4463782B2A7. It says, what are the hexadecimal values for the source and destination addresses in the Ethernet frame containing the ARP reply message? Source and destination addresses, you've got it right here. You could also go back up here and find that destination source. Same thing. And that is destination on this one is the E46CD1F9C499, which is the system we're querying, and then source is us. That's my computer, so that's F4463782B2A7. Let's see, and it says, and now we're going to open up our ethereal trace. There we go. That's the packet for, or there's the file. It says the first and second ARP packets in the trace correspond to ARP requests sent by computer running Wireshark, and ARP replies sent to the computer running Wireshark by the computer with the ARP requested Ethernet address. There's another computer on the network as indicated by packet 6. We got packet 6 right here. And we're going to go ahead and just do that. And it looks like there's no ARP reply. And it's asking why. And it looks like the reason why there is no ARP reply is because there is no device on this network that has the IP address of 192.168.1.117. So that is why that it can't send a response back. Thank you.